Section 2.7 also contains solving absolute value inequalities. We've got two different scenarios here of solving absolute value inequalities. We have solving absolute value that are greater than. The steps to solve an absolute value inequality are the same steps. You want to first make sure that the absolute value is on one side alone. Then you want to make sure that you have a positive number. And then the last thing, we will set up two inequalities, but whenever we change from positive to negative, we are also going to have to reverse the symbol. So let's look at an example. We have example, this is an absolute value, an inequality. Remember, the first step is to put in standard form. So we're going to have to actually solve or move two things. We need to rearrange the -2 to get 3, absolute value of 4x plus 5 greater than or equal to 24. But the absolute value is still not by itself because of the number in front. So in order for us to remove the number here in front, this is 3 times the absolute value, so we will divide by 3. And that's going to give us an absolute value of 4x plus 5 greater than or equal to 8. Now you have your absolute value. Our distance here is positive, so we're going to set up two equations. The first equation is going to stay like it is, which is 4x plus 5 greater than or equal to 8. And your second equation will be 4x plus 5, but instead of greater than, we need to remember to reverse our symbol to become less than or equal to, and change our value to a -8. Once we have reversed the symbol here, and we have changed from a +8 to a -8, now we can solve each equation, or inequality, excuse me. So here we're going to subtract 5, we end up with 4x greater than or equal to 3. Divide by 4, that gives us x greater than or equal to 3 over 4. That's our first inequality. Our second inequality, we're going to subtract 5. We end up with 4x is less than or equal to -13, and divide by 4 again, we get x is less than or equal to -13 over 4. But remember, with inequalities, we have to graph here on this number line, shade, and then determine what our intervals will be. So let's place our two numbers here on the number line. -13 over 4 comes first on the number line, and 3/4 will be to the right. If we look at this inequality here, it tells us that x is greater than or equal to 3 over 4. So if we look at 3 over 4, greater than is to the right. So we're going to shade to the right. This here goes, that arrow means infinity. And we need to determine whether we need a parentheses or a bracket. If it is or equal to, we're going to use brackets. So here we'll have a bracket. This particular inequality, we have x is less than or equal to -13 over 4. Here's -13 over 4. Less than is to the left. So we're going to shade to the left. On this particular end, this will be not positive but negative infinity. And we're also going to use a bracket here because of the or equal to. Our last step that we need to do is write this in interval notation. Interval notation is written from left to right. We're going to have two intervals here. The first interval we're going to start, because all intervals have two numbers or symbols within it. The first one here will be the parentheses negative infinity to a negative 13 over 4 bracket. But because we skip our shading here and we start up another interval, we're going to join this by a U, and we're going to write our second interval, which will include 3 over 4 to infinity. So this reads that it values negative 13 over 4. It can be equal to negative 13 over 4, and anything less than that. This interval reads that our solution can be 3 over 4, or any number that is greater than 3 over 4. Alright, less than, we're going to work the same way. You still follow these 3 steps. And when we get ready to write our 2 inequalities, remember we want standard form. So we're going to get 3y minus 2 less than or equal to 4. We're going to keep the inequality like it is, 3y minus 2 less than or equal to 4, and then we're going to write our second inequality, but instead of less than, we're going to change to greater than or equal to a negative 4. Remember, when we do change from positive to negative, you've got to reverse this symbol. Solve the equation. We're going to get 3y less than or equal to 6. Divide by 3y less than or equal to 2. Here we're going to add 2 again. We get 3y is greater than or equal to negative 2. We're going to divide by 3. That's going to give us y is greater than or equal to negative 2 over 3. We're going to graph our 2 solutions. Negative 2 over 3 comes first. 2 comes second. Let's read this. It's telling us that y is going to be less than or equal to 2. Here's 2. Less than is to the left. Okay, so that means we're going to be shading over here to the left. And then here we read y is greater than or equal to negative 2 over 3. Here is negative 2 over 3. Greater is to the right. So in this particular problem, our shading occurs in between the 2 numbers. And we're going to include here at the number, both will have brackets because it is or equal to. So this interval will include, when we move left to right, now our shading starts here at negative 2 over 3. So we're going to have bracket negative 2 over 3, comma. Our next number will be 2, and we'll enclose it with another bracket. The last 3 examples here is to, what if you have a negative number with an inequality? This reads the absolute value of x is greater than a negative 1. Well, if it was an equation, it would be no solution. But if we think about all numbers here where the number is 1 or negative 1, will always come out to be a positive number when we determine the absolute value. Think about a positive number. Think about positive 1. The absolute value of 1 is 1. Okay? So the absolute value of 1 greater than negative 1, that gives us 1 greater than negative 1. Well, is 1 greater than a negative 1? This is true. Okay? Well, let's substitute in negative 1 because we know that a negative 1 will also give us a value here. So we're going to have a positive 1 greater than a negative 1 again. This is true. So think of it this way. Positive is always greater than a negative number. So here we're going to have all real numbers as our solution. Okay? Alright, well, let's look at this particular example. When we go to rearrange here, we want to rearrange, even though this is a negative number, you still want to get this absolute value equation, inequality, by itself. So we're going to add 2. That's going to give us the absolute value of x minus 10 is less than or equal to negative 1. Now we have less than. Well, let's think about what we did here. We said that positive is greater than a negative. Is positive in this case would be less than or equal to a negative. Is this true? This is not true, because a positive number will never be less than a negative, so this particular solution will be no solution. And this here, you're going to have only one solution, just like with the equations whenever you solve this particular inequality.